Okay, good afternoon and welcome everyone to this second of 5 webinars that we are doing for the Council Aquatic Centre Energy Upgrade webinar series. Today's webinar is about templates for feasibility studies, so to get you started and set your project up for success. My name is Jarrod Leake and I'm the CEO for the Australian Alliance for Energy Productivity, or A2EP as we like to be called, as that's much easier. I'd like to start this webinar with no acknowledgement of the traditional custodians of country throughout Australia and their connections to land, sea and community. And I'd like to pay my respects on behalf of A2EP and everyone here today to elders, past, present and into the future. Just a little bit of housekeeping here. Today these slides will be sent out to everybody who's registered for today. And we're hoping to answer questions. If we keep to time, we should, I'm sure, be able to get to answer one or two. If you have some questions, open up that Q&A box and type that in, or if you see someone else with a similar question, what you're hoping to be asked, just tick that upvote there, and we'll be sure to get to that one. For those of you that are new to A2EP, we are a non-for-profit industry association focused on energy productivity, which is all about getting more value out of less gigajoules, and with that provides smart and fast decarbonisation. We've got a wonderful mix of members that share our passion for saving energy and reducing emissions. And so all this from a range of energy suppliers to energy users and technology providers and consultants and in between. This gives us a really good foundation to carry out the great work that we do. Joining me today from the A2EP team, we have Brendan Vos, is our project manager looking after research for heat pumps and decarbonisation, as well as Alan Pears is our technical advisor and thought leader here at A2EP. Both of them have a fantastic history with working with heat pumps and energy efficiency and really understanding heat flows through buildings and therefore aquatic centres. So I think we're well placed to give you some really good advice today. Just to bring you up to date with resources that we have freely available, if you go to the A2EP website /aquatic centres, you'll find lots of updates of news, like what's happening with the community energy upgrades, also a link to our heat pump estimator tour, technical guides for guiding you through using a heat pump for an aquatic centre, looking at things like refrigerants and what have you. And there's lots of really good webinars there for you as well to bring you up to speed with the latest in technologies. So, aquatic centres. We kicked off this last week, but it's good to give it a little bit of context here. You know, these are an amazing community asset. Aquatic centres often voted as #1 community asset, but of course the very highest of energy and consumption and emissions. So we do need to see this decarbonise and help with cost of living. We need to do this cost effectively. Government is on board to help with that transition as well. The Community Energy Upgrade Fund was announced by Prime Minister Albanese in, I think it was May or June this year, and he said it's going to be open this year, and they are trying their best through government to make sure they hit that deadline. And you'll see there's more information coming out on this one, and it was just released today. And so this is the latest guidelines to say that the amount of funds and everything available between $25,000 and $2.5 million. So that's covering 50% of your project costs. And this will be awarded on a merit basis. Not quite sure what that merit criteria will be. Well, hopefully that comes evident in time. And that's going to cover such things as load flexing and demand management systems, so that you can flex up and down according to the costs in the grid and the emissions in the grid. Electrification upgrades, and that's what we're focused on today, is heat pumps there. But also electrical vehicle charging infrastructure, energy efficiency upgrades, and behind the meter renewables, and certainly all those things really go together to help with upgrading community assets. Just a few key dates. So yeah, you'll have more guidelines are going to be coming out from the government in through December. Round 1 is going to be opened in January, and that way, and then April they'll close. In September 24, projects for round 1 are expected to start being implemented. And then there's going to be a second round. And I assume they're going to do $50 million for each round, but maybe a little bit more in the second round, just so that people have enough time to prepare and make sure they're putting in a good submission. But that second round is going to be in 2025. So in combination with that, A2EP and the Sustainable Business Group were invited to provide a program to support this upgrade fund. And this capacity building kicked off a month or so ago. And Brendan and Alan, we started with a workshop. We had 14 or so councils, and it was our time to listen in the start there. Lots of key takeaways there for us, Brendan.
Sure. Thanks, Jarrod. Yeah, so really interesting workshop with lots of very engaged people from council, from industry as well, which was good. Alan had a lot of very good insights as usual into heat flows and how the aquatic centres actually come together and the thermal envelope, which was great. My biggest takeaway from it all was, I guess, that there was a lot of disparity in around how the projects might have been planned and implemented. And a lot of the feedback centred around what is a good feasibility study and what is a successful project and what does that look like. And I guess that's the premise of this second webinar today. So we've already covered what a successful implementation looks like with case studies, but now we're looking at how to plan before you go and make those upgrades. So yeah, Alan, if there's anything more to add.
I'll see you there, Alan.
Yeah, sorry. Yeah, I think we should highlight to people that we've got another workshop next week where we'll be continuing the exploration, I think, with more focus on financial analysis and myths and tricks of the trade. And I think that should be pretty interesting too.
Absolutely. And that is what we have. So this is the second out of 5. We've got 3 already planned. We're looking forward to some feedback for what we're to do on the 4th and 5th. We've got some ideas already, but we're going to be open to feedback for the 4th and 5th one, which we do in February. We'll also be launching a bit of a networking some networking meetings to help people as they're going through this the program and making submissions to this community energy upgrade fund. So yeah, a good support package there coming for you to encourage everyone to make submissions. And certainly this was the feedback we got from that workshop. Said, yeah, please give us case studies. So and we did that last week. The feedback was, yeah, wow, heat pumps here now viable in all sorts of climates, in all sorts of conditions. Yeah, let's get moving on this. The next one we had, and what we're looking at today, is conducting a feasibility study. We're going to get into that. And then next week, we're really going to get into economics, which is going to tick off a lot of these other areas where people wanted information. So joining us to talk about this today, we have these 5 fantastic speakers, and nothing like getting councils to talk to councils, and that's what we've done here. So you can really understand what and make sure you get the right language and understand where your fellow council workers have come through and where they're coming from rather. So we're going to have Cara Taylor from Northern Beaches, and Nick Yannakis, the consultant from BECA, is going to be presenting with Jack Donkers from Manningham City Council. And then we've got Jordan Lim from Bridgeford Group, who's going to be presenting with Abdul Rahman Hafeel from City of Melbourne. So yeah, you're going to have really take us through their experience of doing feasibility studies and what they've got out of it, maybe a few lessons learned, maybe a little bit of comments from hindsight of what they could have done better, and all in the name of helping you with your feasibility study. Cara, if I could ask you to start sharing and start your presentation, that would be great. Quick intro for Cara. Working with Northern Beaches Council is their Senior Sustainability Officer. I met Cara a few years ago when she reached out to say we've got a few issues with increasing gas prices for their gas turbines and boilers. And from there, I've been working on and off with Cara over the last couple of years, trying to help with guide and help with helping them to decarbonise. So, Cara, great to see how far you've come over the last couple of years, and look forward to your presentation now on this on your feasibility study. Over to you.
Awesome. I'm assuming I'm sharing the right screen this time. Awesome. Good. That's good. First hurdle done. So yeah, I've just wish to acknowledge the traditional custodians of the lands we are all on today, show my respects for elders past, present and other Aboriginal people here today. So I'm with Northern Beaches Council, and as Jarrod said, we've got this wonderful aquatic centre, much loved. It's Manly Andrew Boyd Charlton Aquatic Centre. This was the old, it was an old centre which had, 3 outdoor heated pools that went under a significant refurbishment which opened in 2016, which added on basically the big white triangle that you see there. Our centre has, so in total, it's got 3 heated outdoor pools and 3 heated indoor pools, so 20-metre therapy pool, swim pool, and a little toddler aquatic park inside. Actually, it's kind of big, aquatic toddler park inside. Plus, there's a sauna, steam room, spa, cafe, gym. So quite typical of, a largish fitness centre. We also have heating and cooling demands for our centre, and 3 gas boilers and 2 cogen units. So what does most of our pool heating, or all of our pool heating. And then we've got some instantaneous gas hot water systems spread around the place. So that's basically the centre. 550,000 visitors a year, and as you can see on the top of the big white triangle, we stuck as much solar as we could possibly fit. So that was one of our first steps to try and improve the centre. And yeah, like, I'm the sustainability person. Engineering is not my forte. I knew nothing. I didn't even know how to identify a heat pump when I started this project, but I think I got it now. So from a council's perspective, I think it'd be really similar for lots, if not all, of the councils that are looking to do this. And it's the drivers that got us to get all of the buy-in to proceed with the project, to get it to, at least the completion of a feasibility. Obviously, our net zero targets. So we set them back in 2019. And at the same time as well, we did our climate emergency declaration. Big drivers for the emissions part of the project. And then you get to the sort of more financial side. So gas is 34% of our total council emissions. So that's after we got rid of electricity. Like lots of councils, we signed on to a PPA, which reduced our emissions by about 80%. But then the byproduct of that is our gas emissions went up significantly in terms of percentage. So yeah, 34% of our total council emissions are gas. We, as I think, Jarrod was just talking about before, there is, gas prices have increased, and then there's, sort of a lot of future uncertainty about what that's going to look like as people transition away from the gas network to electricity. There's going to be less people in the gas, purchasing gas, so the network charges will be spread among fewer people. So there's a lot of uncertainty in that space. And also the electricity grid is decarbonising. So as you move forward, you've got to buy less LGCs each year because there's more renewables already in the grid, to the point where eventually you won't have to buy those offsets and the grid will be green renewable, whereas that's not happening with the gas network. So that's another reason to switch. You can see the little pie chart down the bottom. So in terms of what is using gas for council, 90% of it is just this one aquatic centre. So if we can solve this problem and transition that to renewable energy, that's a huge step forward for us. And then I can go and learn a lot about fleet and waste once I finish this project. So yeah, we knew those sort of top 4 drivers. We had those, we had those under control. So it was time to start learning a lot about what it looked like to transition an aquatic centre. So that's when I started hassling Jarrod on and signing up to, workshops. I went along to their workshop a few years ago. And through learning about that and heat pumps and what was sort of happening where the industry was going, we also got reasonably confident that we were going to save money. So electricity is more efficient when you run it on heat pumps. And so that all together, when you take that to your finance manager and you go, I think we can save you money, and you take it to your sustainability people, I think we can save emissions, that set the scene for us. This is a quick timeline, which main point you can see, this is the targets, and then we jumped on renewables. But from a council's perspective, it's really important to get budget. So you can see in 21-22, when it was our budget planning cycle time, we got money ready to start the feasibility in 22-23. We were lucky we had a bit of money available in 21-22 as well to get some additional data. So after going to one of the workshops, I was like, what do I do? And they said, make sure you're getting enough data. So we got a consultant to do a metering. It's just a very brief report for a metering plan to tell us the best way to get that data. And the cheapest, simplest way, most effective way for us was to put a pulse meter on our large gas meter on site. It took a little while because, you know, we had to go through our BMS controller, get quotes. They had to build a board that's Gemina requirements, specifications that has to sit on top of it so you can send the data. Apparently it so it doesn't blow up, so it seemed important. But we got all of that done, and all up it was about 7,000. So not too much to get, you know, that good data, but get it coming in so that you've got it for your consultants. And then again, so in the 22-23, now, you know, we were doing the feasibility, we were getting the budget ready for peer review and tech specs moving into 23-24. So the feasibility that we did, we broke it up into 2 stages. The first stage was looking at electrifying our gas assets to reduce emissions and getting a roadmap for, you know, exactly if we were going to do it, what that looked like and how long it was going to take us. But also importantly, sticking on energy efficiencies, because you've already got a whole bunch of fancy engineers looking throughout your whole system. You're about to increase your electricity usage on site. So it makes sense to also get them to give you recommendations for how you can reduce energy for your other equipment on site. So the electrifying the gas assets and energy efficiency. The second stage of our RFQ at the time, we added on an optional second package for the technical spec for the future tender. And the reason we did that is we weren't ready to, we did it as a second stage because we weren't ready to sign on straight up because we didn't know what the outcome of the feasibility was going to be, but also how much it was going to cost and when we'd be ready to be doing those technical specs. But we wanted to have the option to keep the same consultant because it's going to be the most cost-effective way of doing that. We also included in our RFQ, we wanted benchmarking, which I'm sure you'll hear the fanciness about that from all the consultants later. From my non-technical perspective, you know, we wanted energy use intensity, average energy use per visitor, greenhouse gas emissions. So they were all compared against centres that had just indoor pools and also against centres that had indoor and outdoor pools. We wanted to compare as many us with as many centres as possible too. The report also gave us the relationship between energy intensity and pool area. Apparently, we're lucky, we're winners. We've got a really high pool surface area to gross floor area, which is, I don't think that's what you want because that means our energy use is really high, but yay us. We also got included the energy consumption breakdown. So that's basically so that we know what's using the energy where, you know, how much is going to pool heating, how much is going to domestic water, how much is going to pumps, AC, etc. We wanted to look at all the different types of heat pump solutions. So geothermal, wastewater sourced heat, reversible, were we close enough to the ocean? And also in that, what the refrigerant choices were for those, because that makes a big difference to what's going to happen with your emissions at the end. And like I mentioned before, probably my favourite part of the whole thing is the roadmap, because it gave me a really clear understanding of what I needed to do next and how long things were going to take and what was going to take the longest time for us. We included a compulsory site visit for all of the consultants doing a submission. I think that was really awesome. It was really good to do, understand, you know, where they're coming from. They had some great questions, but also make sure you get your pool coordinator, whatever you guy, you know, the guy who runs the centre or the girl who runs the centre, get them along, because they know what's behind every door, what's to look at. They know how to answer the questions for, maintenance and where everything is. But that was really valuable. We had about 10 submissions to our RFQ, and they were all good quality. It took us longer than we thought it was going to do the assessments, because they were good quality. So we got our internal HVAC specialist to sort of come along to give us some engineering advice in that process as well, and refine the assessments. Just one thing we learned from that as well was there was a lot of experience in like the food and beverage industry, not and sort of new or big renovations for pools. There wasn't a lot of experience that came through for kind of what we're after. Our centre was only commissioned in 2016, so it's kind of new. We're not ready to renovate. We literally kind of just want to pull one out and plug one in if we can, as much as possible. There wasn't a lot of experience demonstrated just for that. So just a heads up, probably more now. This is just a little bit about who we involved. So obviously the two main parties, which is like the blue and the green, is our transport and assets team. They run the centre. They're the operational people. So they've got, they've got the money. They run it, all the knowledge, and then the sustainability team. Also, the little people down the bottom, I would say, are the capital works team. They're going to be taking it over from me, so I don't want them to hate me when it doesn't work out. And I want to include everything we can. And then also our finance team, because I need them to buddy up and give me some cash. But also they're interested in the savings. Obviously, we had a project working group across both of those, and also got buy-in from our directors, which is really important. One interested in emissions and the other obviously in the centre. So quickly, I'll just rattle off a bunch of learnings, because I think I'm getting close to my time, but I have heaps. I'm happy to share with anyone who needs to shout out. But engineers love data, the more the better. Check that your data is coming through now. Your meters, your sensors are working and they're capturing data. How long does your BMS store data for? You may want to go download it. I didn't realize ours gets chucked every 12 months. It's not stored. So go download it, so you can have a longer data set. Get your plans for your site ready. Do you have maintenance records? Start them, capturing them now. Invite yourself on aquatic tours. I unashamedly did that. Love it. Got taken around Brimbank when I was down in Melbourne, and I went out to, was it Leichhardt or Ashfield? I always forget which one. It's great to see it in person. Consider a peer review. We're doing that at the moment on our feasibility, and it's really valuable. And in our initial build, we missed out on a few opportunities. So if you are doing a larger scale refurbishment, don't not include stuff, because some of it we can't build back in now from the original plan for our centre. Consider future electricity demand. You're going to have EVs on site, and don't forget to consider the impact on your electricity bill. You've probably got a allowable load variance. Pretty big centre. Just make sure what impact that's going to have on there. And that's pretty much for us. Like I said, happy to answer any questions as anyone's going through this. I've learnt heaps and I'm still learning.
Brilliant. Cara, wow, that was jam-packed, a lot of learnings and everything into 10, 15 minutes. Thank you so much. Alan, if you want to chime in here, what I heard, I really like the process, identifying stakeholders and getting them involved, getting data, energy efficiency first, looking at benchmarking, sounded great to me. Alan, what do you think?
When Cara talked about the data being dumped every year, that resonated a lot with me. At RMIT, we actually had students coming in early some days to download the data before it disappeared. And you really need a history, don't you? So, but apart from that, really comprehensive and great that you've clearly taken a lot of the key people with you on the journey, which is great. Yeah.
Good one. Brendan, many questions? Anything from the questions Q&A box coming through there?
No, I think so comprehensive. I learned so much in that. But I don't think there was any. There was only one around publicly available benchmarking, like energy usage index data. Like if that was publicly available, and thank you, Kyle, who shared a RMIT study on this. And I know there was one from Aquatics and Recreation Victoria as well that I got a hold of a little while ago. But aside from that, I don't know of anything else. But there's one in the chat, a link if in the Q&A if anyone's interested. So
that's the one from Dr. John Duverge, who we had presenting. We did a webinar with Dr. Duverge about 12 months ago. So you'll find that on our website, and he'll take you through a bit more detail of that PhD that he did. So good one.
there's a late question about cost, I think, and I think that's going to be a common theme is cost for feasibility studies. So we may or may not be able to answer that, but that's the late question. So
quick question for you, Clara. Do you have a take or pay agreement with your gas provider? Are you locked in for 3, 4, 5-year contract or anything?
Yeah, so it depends on the contract at the time, but yes, we are. I think we do it on a yearly cycle at the moment, and we do have minimum amounts. We got stung in COVID because we closed our centre, so we got a $90,000 bill for not using enough gas at that time, which hurt.
Okay, one to watch. Good one.
Yeah, and I'll just want me to quickly answer the other question. So just the question in the chat is how much did we spend on the feasibility? So for part one, it was less than 40,000.
Excellent. Tara, thank you so much. Brilliant. Okay, let's go on to our next speakers now. We're joining us. We have Nick Yannakis from BECA, Jack Donkers from Manningham City Council. We've seen Nick on many different aquatic centre presentations and forums and what have you. It feels like when he's talking, it feels like he's about 5 or 10 years ahead of most of the industry here in Australia, because that's where he's come from, New Zealand, and they've started this transition much earlier than what we have. And so he's got so much to share and has been through so many projects. Nick, I'll hand over to you and Jack to start sharing and take us through your experience with the feasibility studies, please.
There you go, Jack. Yeah, thank you very much. Hi, my name's Jack Donkers from Manningham Council. I'm the Environmental Projects Officer at Manningham Council, and I'm coming to you today from Wurundjeri Wurrung land near the Burrong or the Yarra River. So my role in council at the moment is looking at a lot of our council assets and looking at ESD and solar installations to upgrade assets. And then we've also got a net zero plan for council assets for 2028 and then community for 2035. So starting off, a little bit of background for our feasibility study that we're currently doing at Aquarina Aquatic Centre based in Melbourne. The thing that really started off for our council was there was a lot of talk through different councils about heat pumps and ESD upgrades to aquatic centres. But the really big thing was the FG Advisory Electrification Foundation paper, which showed that across multiple councils, one of the absolute major emitters was the aquatic and recreation centres. And then when we did our own investigations into our billing, we came to the same conclusion. So from that, Brimbank Aquatic Centre opened, and that was an absolutely amazing example of an all-electric aquatic centre. Yes, they are leading, and yes, there have been a little bit of teething problems, which I won't go into. But from those learnings and that improvement on efficiency in running an aquatic centre, we were able to create a business case and take that to our executive management team, not our emergency management team with the same acronym, and say this is what other councils are doing and this is our goals for the future, trying to get to net zero. We believe that our aquatic centre is definitely a major feature which needs to be looked at. What are your thoughts? And they absolutely agreed. We got councillor support as well. Looking at the aquatic centre, we've also got works to revamp our outdoor 50-metre pool, which we'll go into later. And so these works will aligned with those works and try to get as much outage of pool usage done for works at the same time. So it all sort of wrapped up in a nice, neat little bundle, and we were able to go ahead and create a feasibility study from that. So our project, Carina Aquatic Centre, I've got a map for you in a later slide, but basically we've got 5 indoor pools, a 25-metre lap pool, toddler pool, warm water pool, spa and learn to swim pool, 2 outdoor pools, a 50-metre outdoor pool, and then a dive pool run off the same water but is currently not in use. We also do have a water slide which is used in summer. 4 hot water units across 2 plant rooms for the site. It has about 2,500 tons of CO2 emissions, 99.8 kilowatt solar on the roof, and it is part of the Victorian Energy Collaboration, or VECA, contracted building, which basically means we are running all of our grid power from green wind power. So again, when we looked at buildings, we were mainly looking at our billing. And when it came down to costs, about 56% of the costs were based in electricity, 44% of the gas. And at the time, gas was a lot cheaper than electricity. So we knew that gas was absolutely pumping away and is our biggest emitter by far in council. So again, just another little map. You can see the indoor warm water, spa, 25-metre learning to swim and toddler pools, and then outside we've got the 50-metre pool and dive pool. Our centre is a little bit unique in that it was built in 1974, and there have been a lot of renditions and upgrades to the centre over time. And so you can see the multiple plant rooms, you can see that there are new buildings coming on site, and so it's sort of grown and expanded, which makes this one a nice little complex beast. So when planning for the feasibility study, sort of internally in council, I thought today the presentation would sort of be like, who do you go to? What's the best way of starting this and working collaboratively to come up with a plan for your study? So who we went to was, first of all, our sports and recreation team and third party provider who facilitates the building. They have the on-ground knowledge of who's in the centre daily, how the centre's used, the BMS for the centre, as well as operational conditions, so temperatures of pools, temperatures of air, what are some maintenance and ESG behaviours, as well as hardware that need looking at from a operator's perspective, and then going ahead and implementing those into our study. I'm from council's environment team, as well as other members of my team. We were sort of researching other councils' studies and looking at what they were doing in terms of where they were researching, who they were talking to internally and externally, and then using all that information for our study. So we've got our building projects and capital works team. Like I said before, we've got a massive revamp of the outdoor 50-metre pool and dive pool area. That's all going to be basically changed out and then redeveloped in 2024, 25. So we wanted to know all about that, how they're going to do that, maybe looking at how the plant rooms can be encapsulated in that, what's closing, and being able to align our works with theirs. So having that very clear timeline, which is what Cara was really adamant about in her presentation. Also, our facilities management and building maintenance team. So obviously, council asset, big building, it needs to be maintained, and they definitely need to be on board with any upgrades to the site where they will need to look at ongoing maintenance for. So in terms of the planning for our feasibility study, a lot of this came beforehand and a lot of it came after the fact, just learnings along the way. It was really about what documents you have as a council, which can help the contractor get as much information as they can so that they can give you the best educated model as well as outcomes for your site. So obviously ours is a bit more complex than a lot of other sites, but still all of this documentation is probably pretty relevant. So obviously executive management team reports, councillor briefing reports and presentations to go through the planning process of what the actual outcomes are that you're trying to achieve. Capital budget submission, so being able to get the funding not only for the feasibility, but then the ongoing works in the future. We had our tender package. Our tender package was broken down into 3 direct things. So we wanted to be very clear in what outcomes we wanted. The first one was investigate the site. We asked for a level 3 audit. We originally got a level 2 audit in the past, and unfortunately for us and our way of approaching that audit beforehand wasn't enough data for us to make a conclusive outcome for this. So we had to go back out and ask for a level 3 audit. Then we asked for feasibility and feasibility and recommendations for ESG gasification of the site in a wholesome thing. So obviously we've got 2 plant rooms. We've got a lot of different units going on around that site, and we wanted to bring it all together so that it becomes one big wholesome centralized solution, so that we're not running around dealing with all this expansive works. We want everything to work together well over a very long period of time. And the last thing, which from learnings now I would probably change a little bit, is we asked for the design for the degasification and detailed design of taking out the hot water units and putting in heat pumps. However, realizing now that the feasibility to get to that point, there isn't enough information on a consultant's point of view just going around and doing a site visit to be able to determine how much that would cost. So when we actually did get that in our evaluation, we got very varying different prices for that. And that was mainly because it was just really, really hard to come up with a solution to that. Maybe for smaller, simpler sites, definitely the way to go. But for our site, it wasn't the way to go. Then as we got the consultant on board, one of the first things they asked was for the architectural, mechanical, and electrical drawings. So that's pretty hard to get from 1974, but we definitely tried as much as we can to get as much as we could. So again, just to give them as much information as they can so that they can come up with the best model they could, and then deliver best outcomes from that, as well as from that 24 months of electricity, gas, and water billing data and interval data for that site as well. So again, as much information as you can about your site to give the consultants the best picture possible in the way they model and going forward for the site. That's it from me. I'll hand it over to Nick.
Stop sharing there. Check.
Yeah, I'm trying to figure out how to.
Hopefully up the top there, Jack.
Yeah, it says new share.
Okay, I'll stop the sharing from you, and then we'll do that. Do it this way.
Cool. Thank you.
Over to you, Nick.
All right. Hopefully that's working now.
We're good.
Cool. So I guess, so I've got a bit of background in aquatics and come from a Kiwi background, a New Zealand background, and come from the South Island where we don't have piped gas. So have probably a few unique things to come back. Quick little thing about feasibility studies. Big thing about the thing is sort of trying to show you the different bits of a feasibility study and how far you can go, but not all of them are the same. So you want to sort of understand what you're asking for and why you're asking for it for us to respond as consultants to do that. I would say the big thing for us, a successful feasibility study will be one that you participate in, and investing in the feasibility study will set the path and the success of the project. I sort of try to do this in a way to try and put something together in a way of, a basic a business case, a basic, detailed, and advanced feasibility, and sort of brought it down to different things. And all these will be available so you can do it. So I'll sort of fly through these. So a business case is really when you're starting to look like car injected at what your consumption is, and looking at what I call your bought energy. Not all energy is the same. I'll say that up front. So when you get energy bills and stuff, and you're having that data available, you can look at your bought energy, and then you can compare that. That will be a business case. That's how you would stack up moving from the gas to electricity. When you start getting into a basic study, what you want to start knowing is you got this bought energy that comes from, whether it's your gas or your electricity, but then it's doing some work. So at the moment, this site's got a boiler in it, and that's producing some heating to create some pools, heat and pools, and some domestic hot water, and that's what I'll call your raw energy. So this is what an engineer wants to see and understand, because that's how you produce and deal with that. So basic feasibility study will be looking at where your energy is going, and where that raw energy is, and then you can assess that. Simple part of that, to calculate how much raw energy there is, you'll need some calculations. So when you start looking at a basic feasibility, you need to calculate. And the big thing is you just don't want to take out a boiler and replace it with a heat pump. You want to calculate how big that heat pump is. Traditionally, gas boilers were oversized because they were cheap in capital costs, whereas boilers is not. So that's why you want to do it, is for capital cost savings and understanding that. But then you start getting into more detailed feasibility. So if your site's not just simple, you might want to start looking into a complex site. So I've used Aqua Arena, the one we just spoken about. And what we need to do is start understanding the system. So getting all those drawings in the background starts letting us understand as engineers what's driving that energy in the background, what is installed on site. So we start understanding, you got all this, often you have all this bought energy from your bills, and what we're trying to do is figure out where all that energy is going. Ideal world is people have a lot of energy metering on site and do that by energy metering. If you don't have really good energy metering, if you do it up front, it's easier for a feasibility study because you can use the metered data. Also, BMS trends, critical one that I always tell people. I want to understand temperatures of pools, air, and also the relative humidity in a pool hall, and that starts letting us understand the nuances in that. If you don't sort of have all that, what you end up going to have to do is we're going to have to model and calculate all this energy flow. And that's generally done under an energy audit, or what's called energy audit. So what you end up doing is, this is the Aqua Arena site, and this is all the bought energy coming in. So there's the gas, all that electricity that had a bit of PV you see coming in there, and that's transferring all that into, there's the air handlers in there, and heating all the pools indoor, the outdoor pool, domestic hot water, and the general electricity. So that's now having a look at all that. So you can't just quickly do that. That requires some more complex modeling to understand that. That's also got assumptions on that, and having BMS data lets you verify that assumption. Audits is something that's type 1, type 2, type 3. These come from a standard in the thing. So when you're asking if you want to audit something and what level of thing, the critical thing we look for when we're looking at is a type 1 is a broad audit. So you're looking at energy consumption, and I look at this as raw energy consumption because I'm an engineer. So I'm looking at raw, not the stuff you buy, but where it's going to. So that 20% consumption, anything greater than 20% of the site. So this is the site breakdown based on the modeling. So you got the pool water heating and the air heating sitting above 20%. So you'd be looking at the audit around that and changing those and reducing that. A type 2 then goes to anything above 10%. So for this site here, you started adding in the electricity of the pumps and the fans and stuff like that. So we start looking into there. And type 3 would go anything greater than 5. You see all of these are not things. So a type 2 and type 3 on this site specifically would still have the same output, and they wouldn't actually change the audit. There are a few other nuances, but that's just holistically what you're looking at. And what critical, when I look at what the raw energy is, I also, we argue internally at our team about what includes, but we also talk about the heat recovered in a raw audit because it's part of your energy. And actually it's really important because once you understand your raw, your heat recovered, you understand the importance of some of the technologies you implement and what it does. So that starts getting to benchmarking. So again, now you've got some more data, so you're benchmarking, and a lot of people talk about energy use intensities and stuff like that. So this is again the Aqua Arena data, but now looking at comparing it on raw data. And you can do that by lots of different ways: condition, pool hall area by pool area, and doing different things. And it's a tool. Aquatic centres is funny. You've got to be very careful using a benchmarking tool or energy intensities, because it's a tool to let you understand how things are. But I'll say one thing, after over a decade of studying energy use intensities of aquatic facilities, be careful that you understand what you're doing. So what we end up doing is we compare things on a number of criteria, and compare how they should look and whether it should be an above and beyond as you compare what that is. You can't have, if you're on a really energy efficient site, I'll just tell you not to heat it, don't let people come in it, and don't let anyone use it, and we'll make it really energy efficient. And that's not the point of having these facilities. Aquatic, the energy in aquatic facilities isn't easy, so you just be a little bit careful about what you request in that and how it is actually feasibly to achieve. But at the end of the day, your feasibility, what you want to do is probably pull out these gas boilers here, or pull out the gas and replace them with some sort of electrification requirement, if that's the bit, and then you end up wanting to create what that is. So you end up, when you've been able to analyze all the energy and you can pick plant, you then have to have a look at how that would work and install on a system. You can't just pull out a gas boiler and put in a heat pump. Does it require pipe changing? What temperature do you run a heat pump? And all that starts feeding into feasibility, refrigerants and stuff like that also. But ultimately, at the end of that, and this is sort of the output of that steps and processes along the line, is you got, you might be taking existing facility and what the metrics might be, whether it be the energy costs and the emissions, and you're going to have a works often the stages. So you're always looking at your building elements and your HVAC systems for energy improvements. So this is one from the City of Ballarat. We're going through with them. But they had to upgrade the HVAC system, because what they ended up doing that in stages like that, upgrading the HVAC system first, actually ended up saving a couple $100,000 in operational costs. But the bigger thing is why you did that first in the stage was actually it saved about 400 kilowatt plant size by fixing that one element. So you actually end up wanting to do that first to reduce the capital cost expenditure in the second stage of the size of the heat pumps required to go into the facility. Otherwise, you overcapitalize on that. And then in this one here, we started then implementing, once you had a centralized plant for a heat pump, you can start upgrading the rest of the site to utilize that centralized plant and do that. So it hadn't ended up, this one in particular went from operational cost of $1.3 million, and we're estimating it going down to about 410 with zero emissions as it fully electrifies over time. So I'll go back to that original slide, and there's a holistic view that I've taken, and Jack is exactly right about the concept design. You can't price what a concept design, particularly on how hard that might be in implementing the stage and how much that is to do that. It's really nice, and you could put it with a provisional sum and continue with it later, and that's design as well. And also that could be done on an advanced feasibility, but I would almost sit there and draw a line at the detailed feasibility first before you go on further. Complex indoor pools is this when you're requiring multiple stages of doing things to maximize the output. An outdoor pool is much simpler, so you don't need to spend as much in feasibility because it's a lot more plug and play things. But I'll trying to get us back on time and finish there.
Thank you, Nick. Just about 1,000 takeaways in 10 minutes there. Very good. Thank you. I took a lot there. There's sounds like a level 3 audit I mentioned level 3, type 3 that were being used interchangeably there. I think that's under an Australian standard, so I assume that's it. But I noticed in that EUI, there's a lot of different ways you can do that benchmarking, and there's a lot of nuance involved there. So you really want to have that confidence of your contractor consultant understanding that nuance there. Alan, any key takeaways for you there?
Well, first of all, I think Jack's highlighted something that Cara came up with too, which is a lot of our focus has been on indoor aquatic centres, but the reality is an awful lot of the centres have also got outdoor pools. So I think, and outdoor pools, you can't recover some of the energy. So I think maybe we need to look a bit more at those kinds of things. again, actually reviewing and talking to the right people and finding out what sorts of things are likely to need replacement or upgrading or something like that in the next few years, so that you can start to make a stronger case for maybe slightly early conversion and replacement and things like that to help your project kind of get traction, I think was important. And yeah, Nick's comment about benchmarking. My personal view is that every indicator distorts your perception in certain ways, and so having multiple indicators and understanding what they mean is often very enlightening. So I might stop there.
Good one. Thanks, Alan. Brendan, we are behind. Have you got one question from the Q&A box there? On mute there, buddy.
Took myself off mute. I keep muting myself. Not really. I mean, there's a few around technology, which we'll deep dive in another webinar at some stage. And some about economics and OPEX, CAPEX, which we'll cover next week. So otherwise, there is a question in there for Nick about a job in Christchurch in New Zealand, but he can probably answer that himself. So
good, we'll get Nick to answer that one directly. Let's keep moving, or we'll try and get things back on time. Next, we're going to hear from Jordan Lim from Bridgeford Group and Abdul Rahim Hafeel from City of Melbourne. We worked with Bridgeford Group in a webinar about 12 months ago. And the way they presented it, the way they understood energy flows, and their simple thing of doing a histogram of this is how much heat you need at different hours throughout the year. I thought, wow, this is it. This is best practice right there. And so it's great to bring Jordan Lim back from Bridgeford Group and tell us about their experience with feasibility studies and working with Abdullah as well. Jordan, over to you for presentation. I'll get you to come off mute and share your screen, please.
Thank you. I might just let a few to do the introduction first. Can everyone see my screen? I don't know which screen I'm presenting. I've got like the pains of having 3 and 4 screens at the same time. Right.
Yep,
so Hafeel, you want to do an intro first?
Yep, so I will. So hi everyone, my name is Abdurrahman Hafeel. I work as a senior project coordinator with the City of Melbourne, and my role essentially is to overlook and kind of manage the electrification of all council assets. And so just essentially how this process began was a Bridgeford Group were engaged to do a concept feasibility across all of the council assets and kind of help us look at developing a platform that we could use to essentially electrify all of the council assets. So sorry, I think we've lost the sharing screen there.
Yeah, I'm trying to sort of reconnect.
Yep. So
let me know if this is the right one. Are you guys looking at,
Yep.
you know, like 4 pictures of heat pumps?
Yep, perfect. That's
okay.
good.
So like I can't actually see what I'm presenting, so I'm just gonna try and count my luck here.
Yeah, no worries. Yeah, so essentially, yep. So Bridgeford Group were engaged to do a concept feasibility study across all of the council assets, within which, like I think we identified that most of our highest gas consumers were our aquatic centers, and so essentially from there we developed a plan. We developed a plan as to how we want to tackle this and how we want to go ahead electrifying our sites. And one of the sites that we had picked up was next slide, Jordan. Yep, so it was for the North Melbourne Baths. So North Melbourne Baths located in North Melbourne on 246 Arden Street. Essentially, it's an aquatic center, it's an outdoor aquatic center. And so the aim here was to look at how we can replace all the existing infrastructure and get it electrified in a solution that appreciates the use of the site. So the center's actually it's got 4 outdoor pools. It's got a formal pool, it's got 8 lanes and 25-meter pools. It's got a leisure pool, a toddler pool, and also a splash area. And it currently is being serviced by gas-fired boilers, and the boilers have a capacity of about 664 kilowatts with supply temperatures of 80 degrees and return temps of 60 degrees. So just the unique thing about this site, or the unique opportunity here, was that the North Melbourne Baths, given that it's an outdoor pool, we closed during our winter season. And so we essentially had the when for when we wanted this works delivered. We had the why, which is in response to the council's need for climate change and for emergency action. And that's when we pulled Bridgeford Group in to help us with the how and how we could deliver this project. So I will hand over to Jordan for the next slide, and he will take you through the complexities of the site.
Thanks, Hafeel. So like the first step is to actually know what exactly needs to be done, or what can even be done, is to understand how much heating is actually required. So there are 4 tools in total here. We calculated that the peak heating demand of each of the pools, and all of them added up to about 400 kilowatt. It's about 65% lower than the heating capacity of the existing boiler. So this is good news because heat pumps are very expensive. The thermal capacities that you want to install doesn't need to be higher than what it needs to be. So we know that the council buys green power. So that means that if we electrify the aquatic center, it would essentially become net zero. So as engineers, we first look into solutions which we consider that are non-intrusive. What that means is that we try to look into solutions that are just mere equipment replacement type of solution that doesn't impact any operating conditions such as set points or hot water temperature flow. So to achieve this with air to water heat pumps, which is the superior solution compared to electric boilers, the COP is probably only in about 1.5 to 2.0 on average. COP is basically a metric for efficiency. If it's a COP of 2, it means it performs better than, it means it's 200% efficient. So when heat pumps work with a higher supply temperature requirement, like 80 degrees here, the COP suffers. But it performs better when the temperature requirement is lower. And typically units that can achieve this is a bit more expensive due to refrigerant use, and they do not have really high thermal capacities per unit. So this is actually quite a complicated topic, and more than happy to talk about refrigerants and heat pumps and COPs and whatnot in a separate presentation. But for now, if we just focus on just the cost and the financial performance, after upgrading the site, there'll be, it's like upgrading the site would cost about 870 grand. And after upgrading the site, there'll be like a reduction of 50, using North Melbourne baths as an example, there'll be a reduction of 53% in energy, but it will cost 31%, more to run because electricity is still a little bit more expensive than gas, and also because of the low COP. And emissions-wise, it will be twice as bad for a Victorian site at the moment because our electricity grid is not the cleanest. So because this overall result seems like the outcome is all negative, we kind of have to think of an alternative solution. So we went in to investigate. And so as I mentioned earlier, if the temperature requirement is high, heat pump is not very efficient. But what if we lower the supply and return temperature to just about 50 degrees or 45 degrees? So the COP of the heat pump now becomes 3.0 to 3.5 on average. And now, because the temperature requirement is lower, there are more types of refrigerant and heat pump models that can achieve this. And so the only thing that we have to do in addition to the previous measure is to replace the heat exchangers with bigger ones to allow for the heat transfer. So we ended up going with just one heat pump only that can just supply 450 kilowatt. There's a little bit of a 10% buffer there, which total upgrade cost amounts to only about 561 grand compared to what we saw earlier, which is 870 grand. And because of the efficiency of heat pump is now, so much better than what we saw earlier, there's a significant reduction in energy, 78%. And also with the running cost, you now actually have, a saving in cost and also in emissions there. Even emissions wise, it's about 2% savings. That's kind of Victoria for you at the moment anyway. But other states are probably better because the grid is cleaner. So the key takeaway in this, if I can pass it back to a few just very quickly.
Yep, sure thing. Thanks, Jordan. Yeah, so I think essentially, like from a council perspective, like it was very critical for us to like look at the existing infrastructure. Spatial requirements played a heavy role, and just given that with the city of Melbourne, a lot of our sites are heritage listed sites, and that adds another layer of complexity onto any design or any works you want to do. And in addition to that, like looking at your electrical demand for the site, that was one of our first biggest like critical points. And like I think it's very important that you form a relationship with your DNSPs. And because they come along with you on the journey, like your City Powers and your Geminas, like these are like key players when it comes to electrification. And so I think it's crucial that you take them on board and they come along with you on this journey of electrification. I think if I can think of any other key takebacks from this, just even just with planning out your project and delivery, because like the lead times on heat pumps can be quite massive at times. And if you are targeting a certain period of the year when you want to deliver the project, you need to ensure you've got everything lined up and everything is ready to go essentially the moment you have the opportunity. Other than that, I think, well, touched on heritage, I think, which is a crucial one, spatial requirements, because typically, or at least with the City of Melbourne, most of our pool plant rooms are housed indoors. And now the requirement for heat pumps is to have them housed external. So it takes in a very big factor when it comes to spatial requirements on sites. And given that in the city of Melbourne, it's quite like spatial, like space is quite a premium, like it's quite a premium thing. So you need to really look at heavily looking at ensuring that you have like a design that works with the infrastructure in the area and also factors in the efficiency for the system. And I think that is it from me. Thank you.
Now, I just want to quickly borrow the opportunity to also just share another case study from another site to help everyone understand why option studies are important. So this is another aquatic center in Victoria. I apologize, I haven't quite received the permission to share the name of this aquatic center yet because I was still working on a slice just yesterday night. So if you happen to be overseeing this aquatic center, please keep an eye close. But anyway, I want to explain why this case study is important. We were pretty much performing a very similar study to the one that Hafiz and I shared earlier, but this one has 6 outdoor pools. And so the boiler is much bigger than, it's much bigger, sitting at 1,700 kilowatt, and still have underheating issues because one of the outdoor pool apparently had never been operating on winter, but was made to run year round after COVID. So taking the same steps there, we calculated the heat load and found out that the peak heating load is about 2.8 megawatt, as opposed to the currently installed 1,700 kilowatt for the boiler. So does that mean that we have to install 2.8 megawatt of heat pumps? The simple answer is not necessarily, because when we investigate this in detail, the left graph here is basically a heat load profile of the aquatic center, and on the right table is basically a tabulated version of everything on the graph there. So looking at the cell highlighted in yellow here, what that means is that 98.1% of the time, the pool only requires less than 1,685 kilowatt of heating, and that everything else above that, occurs only 2% of the time for the entire year. So therefore, our solution actually is that instead of installing heat pumps with just 2.8 megawatt of heating capacity to meet the peak heating demand, we would install just 1,600 kilowatt of heat pumps to supply 98% of the heating, and we keep one of the existing boilers of the site to supply the remaining 2%. And then this solution, cost-wise is close to $1 million cheaper compared to installing the 2.8 megawatt heat pump. So cost-wise and spatially wise, this is a much more efficient solution. The 2% of gas usage, understanding the push behind electrification, although I don't necessarily love the idea of buying carbon offsets, sometimes this is probably the best way, the better way to go in some instances to offset gas emissions, so that the council can better distribute the funds to do some other infrastructure upgrade to, rather than just spending an extra $1 million just to solve a 2% issue. So this is something I thought worth sharing and worth thinking about moving onwards when there are more electrification works to happen at the aquatic center. And I guess that's from us. I hope this has been helpful. If you guys have any questions, we can help addressing that during the Q&A later.
Jordan, and Fahil, that's fantastic. Thank you so much for that. Yeah, really like that approach, and so crucial that you're lowering that hot water temperature to get that more efficiency. We say whenever we talk about heat pumps in the transition, if you're looking to do like for like, you're going to do it wrong, and it's going to be very, very expensive. So thanks. It's great to see your views on that one. Alan, anything comes to mind from that one?
Well, I think the last example is actually a very broad example, because people are already finding with the whole electricity grid that trying to go 100% renewable is a lot more expensive than trying to go 97% renewable. So in terms of our existing technologies, because we will improve, and that's where what you're doing is capturing a lot of the benefit cost effectively, and you're leaving yourself with a problem. But the beauty of innovation is that we work out how to do better, and hire COP equipment and all sorts of things, sewer mining to get a heat source, or I mean, these kinds of things start to open up over time, which I think is important. Again, we saw an interesting thing here too, where one of the sites has much oversized gas boiler and the other one's a bit short. So again, the importance of good data and good modelling of what's going on is highlighted. I think I should stop there since we're running late.
Thanks, Alan. That's good. And just quickly then, Brendan, we were at Brimbank Council yesterday and they kept their boiler and they've been running for 12 months. And was it they're running for 1% of the time?
Yeah, so 4 or 5 days per year. So hardly even 1% of the time, basically. But it's a good backup risk avoidance type mechanism as well. So that's why they sort of initially did it, but then have found they don't really need to run it that often, which is great. So
yeah,
sure they'll find a way to not run it ever in about a year's time with some new data and all those sensors they added. So
good one, thank you. And Cara, if I can just invite you back in for a moment, you're well and truly on the journey. Any little tips and things you've got from these other presentations? You haven't committed to a path just yet, but any takeaways for you over those last 2 presentations?
I think mainly it was really important going back to that. It's like, what is your main driver? Is it okay to have a gas boiler left for a certain amount of time? I was, when I set out, I was like, oh, we want to break up with it completely, but at present we're proposing the same thing, to keep it as a backup for a little while till we learn how to operate it, have it there for a couple of years, and then I know that the other idea is, you can have plug-in backup supplies, that you can bring in at times, which I know Alan was talking about at the edge. So that's something that would be interesting to look at as well.
Good one. Excellent. Thank you so much. Well, to our speakers here today, that's Cara, Jack, Nick, and Abdua, Rahim Fahifil, and Jordan as well. Thank you so much for sharing your insights today. It's very, very helpful for our audience. Just to wrap up with here today, I've just got a few slides here just to finish off to where we're at with things. There we go. And bear with me there for the moment. Just to talk about our webinar that we have on next week. Next week we're looking into the economics of a heat pump upgrade, looking into the real detail there of the big decisions. These are the decisions that will swing your results of your upgrade by several $100,000 either way. So we're going to look at the idea of the concept of load flexing to adjust the load versus time. We're looking at the electricity supply contract and looking at things like VECs and ESCIs, these white certificate grants. Again, these can swing things hundreds of thousands of dollars. I will also have our own Brendan Vos talking a little bit more about this partial electrification concept and how that can work. So we'll dive into that just a little bit deeper. So that's join us next week at exactly at the same time. And the other one coming up for A2EP, if you'd like to join us on Friday, the 8th of December, we have a webinar on energy-based maintenance and just talking about there's some simple things to do to save energy there as well. So that's all it for today. Thanks again for our speakers. Thank you for joining us. You'll have the recordings and the slides out to you very shortly, and hope you can join us all next week and enjoy the rest of your afternoon. Thank you.